All right, everyone. I just got my new mic set up, and it's got a built-in pop filter, so I should be able to say fun things like publish the payload to the payments processor without many plosives coming through. And we can also say other fun P words. I wanted to make a video today on how to provision and test your AWS infrastructure locally using a tool called Localstack and also Terraform. If you're not familiar with Localstack, it's basically a cloud service emulator that can run in a container on your laptop, and you can basically run your code against AWS services locally. So I'm going to be using S3 and SQS today because I've used those in the past with success. We're also going to be using Terraform as our infrastructure as code provider. If you're not familiar with Terraform, it's a infrastructure as code framework developed by HashiCorp. And you just write some HCL is what they call it. That looks like this, and it will provision your AWS resources. So we're going to be using these two tools today to set up some AWS infrastructure locally and run some Go code against it. Cool, so I've got a bare bones project set up. I've got an empty Docker compose file here. I've got my Go mod initialized, and I've got two empty Go scripts here, one for SQS and one for S3. There's nothing in these, but we'll be adding stuff to that a bit later. So first things first, we're going to get our local stack container set up in this Docker compose file. So we're going to get some boilerplate from the docs here. We've got a nice little snippet that we can just go ahead and copy. So I'm going to go ahead and grab this and just paste it in right here. One thing here, I'm going to add a dot in front of this volume directory here because I don't really want this to show up. I don't really care to see it. So real quick, I'll just start this up, rename this session to local stack, and let's do Docker compose up. Okay, so now I've got the local stack Docker container running through Docker compose. This damn directory still showed up, which is annoying, but whatever. Okay, next we want to go ahead and get our Terraform set up. So I'm going to create a Terraform directory here. I'm going to create another directory called local stack within there. And you could technically have another directory for like your real cloud Terraform, but this will be where I put like my local stack specific Terraform. So I'll create a main.tf file in here. And I'm going to copy a lot of code from the documentation. So I'm here on the local stack docs, and there's like a section specific to Terraform. I'm pretty much going to copy this whole thing here. And actually, I'm going to copy all of this because what I want to do is actually create an S3 bucket first. And one thing to call out here, they put this custom endpoint here. I'm actually going to make it the same endpoint as the rest of these services because they mentioned that you can interchange them. So I'm basically just going to copy this entire thing here and paste it into the main.tf file. Okay. And it's got my AWS access key, secret key, region. This is all mock stuff right now. I'm going to exchange that endpoint, as I mentioned earlier, because we can use this for all of our services. So that's cool. I actually want to update some of these to be injected through environment variables because I will use them in other places. So I'm going to use something called envrc, or something called dir-env, which uses an envrc file. And basically what this does is it allows me to use environment variables that are set specifically for the directory that I'm working in. And this is very useful when you're working with multiple projects and you want your environment variables to be isolated to that project. So I'm going to go ahead and do that. .envrc. And I am going to copy the AWS environment variables here that we need. These are just dummy values, so I will go ahead and just paste those in. And I'll just replace it with dummy. US West 2, whatever. Something else I want to do is I want to be able to use these environment variables and reference them in the Terraform file. You have to do a special prefix on the environment variable to make sure that it is accessible within your Terraform file. And the way that we do that is using a tf var prefix on our environment variables. So I'm going to go ahead and add new environment variables that allow us to reference those. So I'll just say export tf var, and I'm going to set it to the existing environment variable here. So I'm just going to reuse this value and basically have an alias for it so that can be referenced by Terraform. Cool. Now what I need to do is create variables in the Terraform. So we can use variable. The name is going to be called access key. And I need to specify the type of it. I think it's just like that. Let me reference the docs again. So this is how we've labeled it in our envrc file. That's good. And we can create the variable like this. I did this correctly, so now we can reference that in the Terraform file itself. So now I'm going to do this for each variable we want. And I also want this local stack URL to be a variable, so we'll add a variable for that as well. And I want to make sure that I'm referencing the variables here. So this will be var access key. Cool. This one will be var.localstack endpoint. And I need to make sure that I put this localstack endpoint in the envrc file as well. So I will say export localstack endpoint. Copy this again. All right, so that's good. I've got these variables set up. They're being referenced in here. I'm also going to make one for the bucket name. But let's create the Terraform variable here. And technically, you don't have to do all this stuff. I just feel like it's nice to have a single source of truth where I'm defining these values and then just be able to reference them everywhere instead of having strings hard-coded, because now I can actually reference these in the Go code itself when we get to that part. I'll add a variable for the S3 bucket. So I'll just call it bucket name. It's also of type string. I can reference that down here. Var bucket name. Cool. So now this is a good starting point. I want to go ahead and just double check that we can provision these resources. All right, in a new tab, I'm going to rename this Terraform, and we can run cd into our Terraform directory. And I'm going to do Terraform init. This will initialize our Terraform state file. This will allow us to plan our Terraform and then apply it. Okay, so we've been initialized correctly. Let's do Terraform plan. Okay, so this is good. It shows that my plan will provision a S3 bucket and create it. And we've got this one warning here. This doesn't really matter because we are skipping requesting account ID. All of this is already set up, so just ignore this. So now I'm going to do Terraform apply, and this will actually apply this plan. So I have to say yes. So it says it's created these resources. We can use the AWS CLI to verify this locally. We just need to override the endpoint with this Localstack one here. So what we can do is AWS S3 LS. This will list the buckets we have, and we need to specify the endpoint. This will be the Localstack endpoint. And we can see a bucket is there called my test bucket, which is great. So now that our bucket is provisioned locally in Localstack, let's go ahead and get some code set up so that we can interact with this AWS resource. I'm going to go ahead and copy some code again. To this S3 file, or this S3 app, rather. I'm going to do go mod tidy to pull these resources down. Okay, so it's got a default config up here. I'm going to go ahead and create a context that we can reuse in multiple places. And I'll go ahead and reference our bucket name. I think I called it S3 bucket. Yep. So that's good. Before we actually start doing any interacting with the bucket, we need to make sure that we're overriding the endpoint in our AWS config here. This basically allows us to take in a function that can override some options. So here I'm going to say o.baseEndpoint is equal to os.getEnv, the Localstack endpoint. And it needs to be of type AWS string, which is basically a string pointer. So basically this will tell it to not interact with any AWS cloud resources. This is telling it to reference my Localstack resources. So I want to do something like read an object from the S3 bucket. So first thing I'm going to do is actually upload one through the CLI. Okay, so I'm basically just copying the go mod file to this local S3 bucket and making sure that I specify that the endpoint is the Localstack endpoint. Okay, so it looks like it uploaded. Let's just double check by doing ls on this bucket. And we can see that the go mod file is there. Okay, great. So now that we've uploaded that file through the CLI, let's try to retrieve that object using the SDK. So let's call get object input. This takes in a bucket and a key. The key will be the name of the file, so we just called it go mod. And it has to be a pointer, so we're going to use the AWS string type. Let's make sure we use bucket name. Okay, so let's see what's in this output here. So what we can do is just use the io.readAll function here and pass in the io.readCloser here. Check our error, and let's just print out the contents. So what we should expect is basically the contents of this file when we run this AWS S3 script here. So let's go ahead and test it. Okay, wow, dumbass. It turns out that I led you astray. Basically, we did need to use this specific endpoint for S3. I'm not entirely sure why that's the case, but doing this, I can run the script and it prints out the go mod file, which is sort of annoying because when we add SQS, we're going to have to use a different endpoint. So what we can do is say S3, let's call this S3 Localstack endpoint. And we'll just have another one called Localstack endpoint. Which is equal to this, and we'll use it for everything else. Okay. Okay, cool. So we have an example here of S3 working. Now I want to do one with SQS. So now that we've got this new local stack endpoint, let's go ahead and add the variable for that as well. Actually, we already have that one. I'm just going to clone this for the S3 one that we made. Okay. So now this one is S3 local stack endpoint, and we'll add a new endpoint for SQS. This one will use the previous endpoint that we were using. A little bit confusing, I know. Okay, so now I'm going to go to the Terraform docs and provision a SQS queue via Terraform. So let's go look at that. And copy. Delete. Delete. None of this other stuff really matters. I do want to add an environment variable for the SQS queue name. Okay, and I will expose it through Terraform as well. We will add a variable for this. And now I can reference that variable for the queue name. Cool. So I'm going to go ahead and run a Terraform plan to see what this looks like. I've got a directory here already, so let's go ahead and do that. And okay, I just refreshed my environment variables just in case. Let's do Terraform plan. Okay, So it shows that it will create a new queue, hopefully. So let's do Terraform apply. And I think I can do auto approve. And it should create our queue for us. All right, I don't know why this is taking so long. It's just local. Cool. Thank you. All right, so now let's just check that it exists through the AWS CLI. So I think we can do AWS SQS list queues, and then we can say endpoint is equal to, we can do Localstack endpoint. Cool. So that is our queue that was created, and it has a custom queue URL there. It is using the actual name, my custom SQS queue. That's cool. Now I want to actually copy some SQS code and get a Go app running. So all right, I'm actually going to copy these. And I'm going to copy some of the previous code we had. Okay, so I've got a config here. Let's go ahead and get our context. Let's get our queue name is equal to os.get SQS queue. Did I call it? Yeah, I just called it SQS queue. So that's cool. Let's get the endpoint. Let's call this Localstack endpoint. And just a reminder, we renamed this one to S3 Localstack endpoint, and we're using the other one here. So let's go ahead and say queue name endpoint. Okay, so we've loaded our default config. We've overridden our endpoint. We actually need to make this SQS. I did a go mod tidy because some of these were not being pulled down. So I've got a SQS client here. Client.getQURL. We're going to get the queue URL first from the API. I could just copy and paste it, but we'll just go ahead and grab it. Pass in the context and SQS get queue URL input. Fill in these fields. We just need to pass in the queue name. And AWS accepts a string pointer, so we just wrap it in aws.string, and then we can pass in our queue name variable. Now this call will get us this URL that we need. So we'll log.fatal. Now what I want to do is via the SDK publish a message to the queue. So we can do client.send message. We can do send message input. I'm going to fill all these in. And the only thing we need to pass in is the queue URL and the body, which will be a string. Okay, let's go ahead and get the output. We're actually not going to use the output, so I'll just set it to an underscore. I will also check the error. Okay, so I'm going to go ahead and run the script, which is go run cmd SQS main.go. Okay, I am in the wrong directory. Let's do this. Go run main cmd SQS main.go. So this script has run. I should see a message. Using the AWS CLI, we can see if the message is in the queue. So let's do AWS SQS receive message. We can say queue URL, which we had over here. And then we can do endpoint is equal to end Localstack endpoint. Okay. All right, that was not there. So let's run the script again. All right, that sucks. Why didn't that work? Okay. I randomly ran it again and the message showed up. So I'm pretty sure that our Terraform has delay seconds 90. So let's make this like 2 seconds or 0 seconds. And I'm going to rerun the script again. Okay. So now we can receive the message and there it is. It's showing up. So be mindful of the settings that you're putting here. I just copied and pasted them. Be aware of what you're doing. Okay, great. So in this video, we were able to provision our AWS infrastructure locally using Localstack and Terraform. I've personally used these tools at work to test some end-to-end services, and I found it extremely useful, especially for S3 and SQS. So I just kind of wanted to share this information with you all because I think you might find it useful. And I also know that these were pretty trivial examples, but I sort of wanted to lay the groundwork for some cooler projects that I'm planning to work on this channel in the future. So I hope you enjoyed this content and found it useful. Don't forget to subscribe for more videos like this in the future. So you guys take care. I'll see you in the next one.